Hello, I'm Neil deGrasse Tyson, your host for Nova Science Now. Most of what we know about ancient life, and I'm talking millions of years old, comes from these things, fossils. You know, they're actually rocks. Over time, the bone and tissue has been replaced by minerals, but there's only so much you can learn from a rock. Think about how much more you could learn if, instead of a rock, what you found was the real thing. Peter Standring met some researchers who've uncovered some rare remains.
Bones tell us almost everything we know about dinosaurs, the fantastic variety of species, their titanic size, their sheer power. The frustrating thing is that there's still so much we'd like to know that dinosaur bones haven't told us. Were they warm-blooded or cold-blooded? How different were they from modern reptiles? To solve these biological questions, today's paleontologists are starting to explore radically new clues from dinosaur skeletons. Christy Curry-Rogers cuts into their bones to examine the pattern of what was once living tissue.
And is it sort of like CSI for dinosaurs?
It can be, sure. Sometimes it's kind of a different method of detective work. We can see in these cross-sections of bones evidence of pathology, evidence of dinosaur disease, and evidence of dinosaur bones breaking and healing themselves. All of that stuff is available via the inside look at a dinosaur bone.
Analyzing the rock that entombed dinosaur fossils is key to understanding how they were preserved, which is the work of Christie's husband, geologist Ray Rogers.
And I'm there to try to place the discoveries in context, to try to find clues as to where maybe best to look for fossils. We've been pretty lucky in Madagascar.
For the last decade, the African island has offered Ray and Christy Rogers a spectacular excavation site. They work in an area of remote grasslands where dinosaur bones literally cover the ground. An ancient graveyard where an unusually large number of dinosaurs died and were entombed by mud flows that preserved their bones.
The preservation is unbelievable. The quality of the material is exceptional. This is a piece of bone from the Madagascar locality. It, in many regards, doesn't even look like a fossil. It's unstained, it's very light, it's not heavily, densely filled with minerals. You look at a dinosaur bone in a museum and it's brown, it's black, it's heavy as can be.
Heavy because fossils are no longer hollow bones. Buried in the earth, empty channels inside the bone fill up with minerals, becoming dark and stained, hard as stone. In some cases, the bone tissue itself is completely replaced by minerals. It's difficult to probe dinosaur biology with bones that have turned to rock, but the Madagascar fossils were sealed in a clay-rich mud, preventing many of the chemical changes that happen to most dinosaur bones.
This is typical of the Madagascar material. It is not heavily stained. It's not been invested with iron, with manganese. It doesn't look like a typical fossil. If you didn't know, you might think you're picking up a cow bone today, a bleached cow bone.
I think this piece might be good, or maybe...
The Madagascar bones are so perfectly preserved that Ray and Christy wondered if they might conceal clues about how these dinosaurs lived and why so many of them died in the same place. To find out, they turned to their colleague, Mary Schweitzer, a paleobiologist whose study of ancient cells and tissues might solve the mystery.
We know that dinosaurs had to have cells, bone cells and muscle cells and gut cells and brain cells, and that's one of the reasons we can study them even though they're extinct.
Schweitzer's career defined itself in her native Montana when she was preparing one of the largest skeletons of a Tyrannosaurus rex ever found.
I was working on the leg bones, and as I worked, I noticed a bunch of stuff. It was like, you know, this bone, there is hollow inside. And I was looking at this thing thinking, this is really interesting.
It was the inside of the T-Rex bone that fascinated Schweitzer, who made thin sections out of it. And in these cross-sections of fossilized bone, she saw something that she and everyone else had thought was impossible. Round structures that looked like red blood cells. Dinosaur blood cells.
Inside those channels where the blood vessels would have run were these little round red structures that were all kind of lined up like a train, and they were bright red and translucent. Nobody else had seen anything like that before.
The very idea of blood cells in a 70-million-year-old bone was more than unconventional. It was radical.
Nobody was imagining that dinosaurs might have had preserved soft tissues.
Derek Briggs is curator of invertebrate paleontology at the Peabody Museum at Yale University.
So along comes Mary Schweitzer, and she's starting to look inside dinosaur bones and has made this startling discovery about the presence of red blood cells. What was your initial reaction to that?
Oh, I think the same reaction as everybody's, that this was totally improbable. She'd perhaps misinterpreted the evidence or was exaggerating the potential for what she was seeing.
So skeptical at first?
Oh yeah, definitely.
Paleontology has been around for some time.
One of the oldest professions.
One of the oldest professions. Has anybody else that you know of found similar things inside a bone?
No.
Why do you think it didn't occur to anybody?
Well, because we have this clear understanding that part of all biological cycles involves decay. I mean, nature is set up to break down that material and recycle it. So it's just improbable that those kinds of very delicate structures would survive, particularly for millions of years.
When you think about it, the laws of chemistry and biology and everything else that we know say that it should be gone. It should be degraded completely.
But Schweitzer kept searching for organic remains where no one had thought to look before. Her mentor is Jack Horner, one of the most famous dinosaur hunters in the world. When his team found another beautifully preserved T-Rex in the remote Montana Badlands, the massive leg bone had to be broken in half for transport, and Schweitzer got to test fragments from deep inside the bone.
The T-Rex bone was filled with a very unique bone tissue. When I turned it, like that and looked down on it and saw this tissue that you can see right there in cross-section, I knew what it was.
It's called medullary tissue, and it's what female birds build up inside their bones as a source of calcium for the eggs they lay. All dinosaurs laid eggs, and it made sense to Schweitzer that female dinosaurs produce the same kind of bone tissue. It looks different from the surrounding bone, and it meant the T-Rex had to be a mother, expecting a clutch of dinosaur eggs.
It was really exciting for me. I thought, there's nothing in my career that could possibly be cooler than being able to identify the first pregnant T-Rex.
No one had ever identified medullary tissue in a dinosaur bone before. But to be sure, Mary Schweitzer directed her lab assistant to soak the bone sample in an acid solution to reveal its structure so she could study it. What happened next would change the way that scientists thought about fossils forever.
As I was looking in the microscope, the medullary material was no longer hard, and what was left was this curled piece of tissue that I was using forceps to try and flatten out. And when I poked into it, it was spongy. It was flexible and soft tissue.
Flexible tissue from a 68-million-year-old dinosaur?
Blood vessels.
There they are.
Transparent, hollow, pliable, flexible, branching blood vessels that contain small, round, red microstructures floating in the vessels. I said, this is not possible. Do it again. We got another piece of bone. We put it in the solution. We waited 2 or 3 or 4 weeks. Looked again, more blood vessels. We must have repeated that with probably 17 or 18 different fragments of bone.
As soon as Schweitzer's discovery of dinosaur soft tissue was published, people thought of one thing. Could we get a real-life Jurassic Park? No